Okay, so just for the next few days, we're going to just be doing some basic skills that you're going to need for the next unit, and we'll start that after the break, especially with there's field trips on Friday and stuff, so we're not going to do anything new there either. So just today and tomorrow we'll have some Delta Math assignments. But just to kick it off, just a reminder that everything we're about to do is going to be conic sections, which are equations of parabolas, circles, ellipses, hyperbolas. And it's a heavy equation-based solving, right? So you have to be good and sharp at your skills, and these are some of them that you're going to use throughout all of those. So first thing is that every radical, just like a fraction, you can reduce or check for reducing, right? And you should do that no matter what, right? So on here, reminder that to reduce radicals, that you want to break it up into something that you could take the square root of times something that you can't. So, for instance, here's what not to do. You would not want to do this because you can't take the square root of either, even though 2 times 10 is 20. That doesn't work because you want one of these to be something you can actually take the square root of, aka a perfect square. You want one of them to be one of these numbers, right? So all these numbers are perfect squares, and then you could take the roots of them, right? So you have to, instead of doing 2 times 10, you would have to do 4 times 5, which, of course, 4 you can take the square root of. So just a reminder, anytime you're doing radicals and they're all over the place, that this is expected that you do this no matter what. It won't be in the directions, just like it's not when you reduce a fraction, you just do it automatically, okay? Go ahead and do number 1. Break that up into, and reduce that. Square root of 90. Okay. And what'd you get? Square root of 9 and square root of 10, which is 3 root 10. Just like that. Okay, no problem. Next, we got midpoint formula, just finding the middle, right? So your answer, you want it to look like this as in a coordinate. So the number one thing here is not really getting it wrong, but I see people just don't write their answer right as a coordinate. So you want this to be as a coordinate. So on here, don't pay attention to the numbers, but pay attention to how you're writing it down. So 3 and 6, you want to find the middle of those, because really we're just finding the average, which is the same as the middle here. So we would do that, and then we would have 5 and 9, and we'd do that. Okay. Divide that by 2. Now, so the biggest thing here is not that you get these answers, but you don't do this. So if anything, if you're that person, there's always a few. If you're not writing this, start writing it. So it's an actual point when you finish the problem, as opposed to, well, I got x equals here and y equals here, but it should be written as an actual coordinate, right? So we have, what, 9 over 2, comma, 14 over 2, in parentheses, right? In parentheses, as a coordinate. And then if you need to, depending on what we're doing, you might write 9 over 2 as 4.5 or 4.5. And of course, 14 over 2 is 7. So definitely, this part, not optional. Not if you feel like it, not if you want to do it. That, since the answer is a point, hence a midpoint, it should be written as a point, a coordinate. Okay? So make sure you do that. Go ahead and try that on number 2. Okay? So we should have 1 comma negative 5 written as a coordinate. So this, and this should be here. Next we have distance formula, which is really just a solved version of Pythagorean theorem. So we start off with c squared equals a squared plus b squared, and take the both square root of both sides. I have c equals square root of a squared plus b squared. That is the distance formula. Instead of c, we call it d. And what we have here is a is the distance between the two x coordinates, b is the distance between the two y coordinates. So the reason why it's subtraction is that if I want to know, well, how far is it from 6 to 2, like how far or how close are they to each other, what's the distance between them, you would do 6 minus 2 and you get 4. That's how far apart they are. So anytime you want to find the distance between 2 points, it's the difference, right? That's why these are subtraction. And the reason why this is addition and these are squared is because it's based on the Pythagorean theorem. I say all this because if you understand where this distance formula comes from, you don't really have to memorize it. It just makes sense, right? You don't mix up formula, the signs or anything like that. Some people accidentally put this a minus or something, but if we understand why, then that will not happen. Okay? So let's try just a few here. So start off with d equals, distance equals. And I'm going to do, let's see here, my x's. Here are my x values. 3 minus 6, or either way. Squared plus my y values, 5 minus 9. Now, you'll notice that some people would say, but the formula says x2 minus x1. How come I did the first point minus the second point? And what's a good response to that? Yeah. Right. So if I did 6 minus 3 or 3 minus 6, it's going to come out to, yeah, it even comes out to negative 3 instead of positive 3. It's squared. You get positive 9 anyway, right? And this also illustrates the point of why, or the reminder, I guess, of that the distance from A to B is the same from B to A. Like where I am standing to the door is the same as the distance from the door to me. So it doesn't matter which one you call the starting point and ending point, right? It's the same distance either way. So it doesn't really matter. Okay? Just so you know that as you're doing your work, that if your formulas look slightly different, you'll still get the same answer. And of course, at this point, if this was something like square root of 48, you would actually go through the same process we did earlier and reduce it. But here, square root of 25, of course, it's just 5. Always reduce when possible. All right, so that's the distance formula. So check. Go ahead and do number 3 here. Give that a go. And as you're doing review, if you know how to do it and it's pretty common sense, focus on how you're writing your work, how neat it is, how thorough it is, legible. That way you can still make an improvement on something by practicing it. So, of this whole problem, right? The thing you have to remember to do is reduce at the end. Which, how does 52 factor? What are the factors of 52 with one of them being a perfect square? 413. Good. So we get 2 root 13. Good. Very nice. let's see here. Next, completing the square. So I think this is from Algebra 2. Yep, it used to be in Algebra 1, now it's in Algebra 2. But just a reminder, what is completing the square? What are you doing? What square are we talking about? Alright, sometimes that's a little confusing. So here's a square. And we're breaking this up into different parts. So we have an x squared, we have 6 x's, but remember on a square, both sides, the base and the height of a square are the same, right? So if I have 6 x's, I really have 3 on each side. So the way this goes is it looks like this. So I got an x here, an x here. I have, and these together make x squared when you multiply. Then I have 3x here and 3x here. So of this 6x, I break it in half because I have 6 x's for the whole thing, so I have to have half on each side. And that's why the first step is take half of b, is because you're taking half for the base and half for the height. Okay? And then the question is, the c is, if I break up this 3, if I write 3 of them, okay, so there's 1, 2, 3, this direction, and 1, 2, 3, this direction. This c value, the part that makes this an actual square, right, is right here. So they're asking how many little squares there are, right? So in this case, there are 9. So that's the value that completes the square or makes a perfect square. The x squared, this 3x and this 3x make the 6x, and I need the 9, and then I have an exact perfect square. Now the reason why we like a perfect square right here, so the area of this square is x plus 3, x plus 3 and x plus 3. Okay. Yeah, so it's plus 3. All right, so I have that on both sides, so we can write it as x plus 3 squared. That's the perfect square trinomial that they're talking about that we can factor. Okay. And the reason why you like this is that when we start solving, doing a bunch of work on these, we'll have a number over here, which could be anything, and then we can take the square root of both sides, and we can get answers and x-intercepts, foci, and all sorts of other values, only when it's in this format. So it's good to know how to complete that square. And notice that if this was 10, right, instead of 9, it would have an extra square over here, which it would not be a square, right? And if this was, this was 8, and I only had 8 over here, I don't know if that's going to work, but yeah, this was just gone, right? If I had 8, now I don't have a perfect square. I have almost a square. It has a little notch off. So that number is the exact number that needs to be perfect there to complete the square. Okay? And it's the same steps for all of them. So like here, all I did really is I took 6, whatever the b value is, took half of that, get the 3, and then right here, 3 to the second power is 9. Right? So it's a nice little pattern. It works for all numbers, no matter what. So try over here. All right. Take half of 8. Have x minus 4 squared. And then 4 squared is 16. So you don't need to actually write out a square and show it visually, but you can understand that's exactly what's going on. And it doesn't matter that this is negative or positive, it works the same. Okay. And next we have, one more. Go ahead and do this one. So one of the things, by this point, you definitely don't want to say, but fraction, this is harder. It has 5th grade math. What do I do? Don't ever do that the rest of your life. Not that many you are, but there's always one that says, but wait a minute, how do I do this one? Do nothing different. You do the exact same steps that you see on the other examples. Nothing changes. Just, don't fake yourself out. There's just sometimes a propensity of Well, at some point, fractions were difficult, so every time you come across one, you stop and pause and say, but now what do I do? Not knowing, you just do the same exact thing. Like if the first one was 6 times 1/2, this one was negative 8 times 1/2, well, this one should be 3 over 2 times 1/2, right? Don't change a thing. Does the answer come to a fraction? Sure. Is that a bad thing? No. Square it. And then our C value turns out to be 9 over 16. So it doesn't matter that's a fraction, works the same. Anytime you have a odd number B value, you will get a fraction. Because if this was just 7, then I'd have 7 over 2, and that would be 49 over 4. Right? So anytime that's not an even number, you're going to end up with fractions. So you have to be comfortable with that. But it's not more difficult. Don't tell yourself, well, this one's harder. How do I do this one? Just do the exact same steps, and it should work out fine. All right. So lastly, on the back side, perfect square trinomials. So this is like the reverse of this. So if you're given this final answer like this, can you work your way backwards and get this? So from x plus 3 squared, can you get 6 and 9 from having a 3 here? So it's kind of the same thing. If we took half to get here, it makes sense to go the other directions, that we would double this number to get the b value. And we're still squaring this number to get the c value. Right? So we can do that right here. So if I have x plus 5 squared, I can have x squared, double this number here, and then we could do 5 squared here. So just like that. So we can multiply these out quickly without a problem. Try the last one here, then we'll do the first one together. So the last one, what's the expanded trinomial that you get? Okay. Should have this. And then lastly, even if there are no numbers, just follow the same pattern, right? So we'd have an x squared here. How do we get this number on both of them? We just doubled what this is. So if it's just a, we'll just double a, 2 times a. And of course, there's also the x on here, so we got to have an x there as well. And how do we get here? We just squared 5, squared negative 7. So here we have a, just square a. Okay. And the most important thing here, you saw how easy this was. And from a long time ago, I still, at the beginning of the year, I mentioned this, that there's still some people doing this stuff. X plus 5, x plus 5, x plus x squared plus 5x plus 5x. That's 25. Then you combine these, and then you get plus 10x. That's 25, and that's x. So this should be done. So for the rest of your life, this is going to be retired. This is like training wheels. At some point it was necessary, and you kind of learned it and maybe learned some factoring from it. But at this point, you saw how quick it was just to do this. And when you're doing like this step, like maybe 3 or 4 times in a single problem, you don't want to clutter everything up with something like this that really is not necessary anymore. Just to do basic multiplication and basic factoring, one of those things you want to let go and just be able to say, oh, I can double 5, I get 10. 5 squared is 25. Okay, that's where we should be. And so practice it doing this way. It might be a little slower at first, but then after a while, it's going to be way faster than doing these things over and over and over, 3 or 4 times a single problem. And when you got 15 of them, it just looks like a big mess. So that's all. Okay, so your homework is going to be on Delta Math, just to practice this kind of stuff. All right, and we'll have another little review tomorrow as well during class.